Welcome everybody. I've just done two videos with kind of a basic introduction to the idea of variables, these virtual containers that we can use to store values or lists or objects in. We'll get into some of that more advanced stuff later on. And then some of the system variables, these variables that exist in the background automatically in P5. And that we don't have to make, but they are there and we can use them. So again, you can check out those videos in the playlist. I do want to point out one little thing before I get into that, and that is if you're watching all of these in a series, I will occasionally kind of go out of order. I'm not just going to work my way all the way through this textbook chapter by chapter. I will ultimately be doing that, but some of the things I've already recorded videos for, other things I may have to wait and come back to later and skip as I'm just kind of building this collection. So basically what I'm getting at is these videos may or may not be filmed out of order if you were to watching them after the fact and going through in the order of the textbook. So sometimes the audio quality or the video quality may change. Sometimes you might see me in the bottom as I change how I'm doing this thing, and as I just get more and more used to the idea of doing these lessons and streaming them in real time. Just wanted to do that because I started this one, realized I didn't talk about some of the system variables, so I'll be going back after this to talk about the system variables in a separate video, but technically that one will be before this. So that's just why I wanted to bring that up. But before, we'll just kind of leave that there and keep going. All right, so I've got this here as a code here. I've played around with the size of my canvas just to give us plenty of space here to work with. Because what we're going to be doing is going around and moving this shape across the canvas. Now, one thing I do want to point out is that the computer is not going to recognize this shape as an entity in and of itself. It's not going to be like, oh, that's the green rectangle. This is just a collection of numbers that we are updating, and the computer just happens to be plugging them into its own internal functions. Later on in this course, when we start talking about objects and classes, we'll talk about how we can make a specific object that is this thing that the computer will recognize as its own unique entity in this collection of values. But for now, we're just going to make a square move across the screen using math. But keep that in mind as we go along, that this rectangle is just a collection of numbers. And that's kind of the core basis for what we're going to be doing here. So we've already made this with the variables here, these values. And since these are just containers that can store a value, we've played around a little bit in the previous video with just being able to adjust them. So if I was to go in here and say, rect y gets assigned the value 500. We've now changed that from when we started off with 150. We've now set it to 500. So you have that there. And it just happened so fast that we couldn't see this change. So we have that there. So how can we go about this? Well, like I mentioned, this is all just a collection of numbers and data. So we can go in and just use simple or complex, but for this one we'll be doing simple math in order to affect this data. So I want to say that, let's move this horizontally first. If I want to say rect x is going to get assigned a new value, only we're not going to type in a hard-coded number like we've been doing before. I'm going to say it's going to be assigned the current value of rect x plus 1. So now you'll see that we're starting to move. So what is happening here? I'm going to pause this because otherwise we're going to lose our shape. So the draw function is reading everything in order from top to bottom as it goes. So the very first thing it's going to do is it's going to put this new background on the canvas. It's going to set that fill function to green. It's going to draw a rectangle using these values that we passed in from these variables. And then the very last thing it's going to do is it's going to take rectx and it's going to assign it a new value. And what that value is going to be is the current value of rectx plus 1. So in order to see this, I'm going to console.log, and I'll talk about console.log in my system variables video a little bit. Basically, we can just use this to get values back from our code. It'll be a useful tool as we start building more complex codes. But I'm just going to say rectx. All right. So what this will do is this will tell us in our console what the current value of rectx is, and that's going to be part of our draw function. So the draw is going to do, boom, 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 and then it's going to loop again and do it all again and all again and all again. And the key to this, as you'll see, is because we're assigning rectx whatever the current value of rectx is plus 1, we're going to draw it in one frame with the rectx. So the rectangle's position, rectx, is going to be 150. And the next frame is going to be 151, 152, 153, and so on and so on. It's going to increase that value by 1 every frame. And since we are using that variable to determine the x position of the rectangle, then that is going to move it horizontally to the right across our canvas as it moves from 0 to positive infinity. So if I run this, you'll see that now our rectangle is slowly moving across the screen, and I'm just going to make this a little bit bigger, but now you can see that this value is increasing by 1 every frame. And that's what's happening. And eventually we're going to run out of space here, and that's the end of the canvas. You'll notice that we no longer see the shape. It's not on the canvas, but this value is still going up. Just remember, the canvas is the part of the code that you are able to interact with in your computer. So if I was to embed this program on a website or something, we would have an area of 1,000 by 1,000 pixels. Well, since this is now bigger than 1,000, the computer is still hypothetically drawing this rectangle there. We just can't see it or interact with it. It's hypothetically way past the edge of the screen already. So it's there. This will keep going essentially for as long as the code is running. Later on, we'll be kind of building in ways to restrict these things, keep everything on the canvas, switch directions, things like that. But for now, I'm just going to stop it. That's for later videos. But that's how we can do that. One thing I want to point out is what I mentioned earlier is the only reason this is working, how we're expecting it to work, is because we're essentially just routing these numbers to the right places. So we have rectx starts at 150. Well, we happen to just be using rectx to affect the x position of the rectangle. And then we're increasing it by 1. If I was to go in and make this rectx and make this recty and run it again, now our rectangle is moving down. And that's only because, like I mentioned, this is just a collection of numbers. All right, the computer doesn't automatically say, hey, that's the variable rectx. Why it's controlling the y value, that's not okay. No, the computer doesn't care. So you got to make sure that you're essentially putting all of the right variables in the right spot with the right name. Again, this is why names are important, so you can do this in order to move your things around how you want them to move. So that's why we have that going there. Because we're still only updating the rectx variable, only now we're moving in the y direction. So again, that's why that might want to you want those names to be proper. If I have them both as rectx, since we're using this number for 2 parameters, now we're moving diagonally. I'm going to put this back as recty for now. So we can do that. So that's basic addition. We can do subtraction. So if I say rect size gets assigned, and this is just the language here, the current value of rect size minus 1. We have that there. I'm going to make this bigger to start with and say 800 for there. But it's going to be minus 1. And since we're using the rect size variable to adjust the width and height of the square, as I run this, it's going to start off much bigger, and it's going to slowly decrease. There we go. I'm going to comment out this other line real quick just so we can only see it shrink. So it's not also moving. There we are. So we see it shrinking. It's eventually going to start getting into a range of numbers where the computer won't be able to draw the square anymore. Or not. Okay, with negative numbers, I mentioned this in a video but never explored it. It's now going, so we're starting at this top left corner and we're drawing it negative so many pixels and negative so many. Sometimes you can get into errors in certain programs that aren't very well built, but P5 has a fight against that just because it's, trying to go back from where it already was, but it's already made the thing. The point is, if you have a negative number, you can go the opposite direction and have that be the bottom left corner. I don't recommend that. I always just say make it the top right corner and go from there. Just makes it uniform. But so you can do basic addition, basic subtraction. What else can we do? We can do multiplication. That's another one. Also, let's say rect y will be assigned the current value of rect y, but we're going to multiply it by 1.1. You notice that is much faster because we're increasing it by a greater value each time. In fact, if I change this to be console there, we're starting to get much higher values much quicker. It's an exponential increase in values every time the draw function happens, and we're just getting so much bigger right away. So this shape is long gone. It's never coming back. But you can do things with multiplication as well, just like division. So rect x equals the current value of rect x divided by, I'll say 1.1 again. So this one, because you can't ultimately divide by 0, it stops getting as close to 0 as possible. Or I should say it's pretty much as close to 0 as it can get without actually touching 0. So I can put this back at rect x on our console log. You'll notice this number is continually getting smaller and smaller and smaller, but it's never going to actually hit 0 because you can't divide by 0. But it's going to get effectively right up to that point because you can't have, a decimal point of a pixel. It's just a pixel. So that's just it. It's just going to be right there. I'll make this a little smaller of a square. You notice it kind of starts off quick and then slowly gets a little smaller. So that's some of the basic math. There's one more that I want to show you all. Let's see. And I'm going to do this with rect y just because I haven't done it as much. Rect y gets assigned the current value of rect y. And this is going to be modulo, let's say 100. Did I hit the right button? Did I use the right syntax? We're going to look in the book because I was expecting this to be a thing. Yeah, %. Go down to the example. It's one of these. Yes, I got ahead of myself. We need a system variable that I haven't taught you all about. So this is frame count. So from as long as the program is running, the system variable frame count is monitoring how many times this draw function has looped. So every time the draw function is going to draw what it has in its function, that's going to be a frame. And then it's going to loop again. That's going to be a new frame, new frame, new frame. And the frame count just counts how many times that happens. What modulo does, for those of you who aren't familiar, if you divide one number by another number, you're going to get a remainder value most of the time. And then that remainder value, that is the modulo. So if I change this to be console.log rect y, we're going to slowly get this going up because we're dividing the frame count by 100, and then whatever value is left over, that is going to be what the new rect y is. So it's going to increase until it gets essentially to 99, and then when the frame count is equally divisible by 100, it's going to be back to 0. And since we're setting that 0 to be rect y, we can see our shape is jumping back. And if I were to increase this to a bigger number, we can see it moves more, and then it's eventually going to increase until it gets all the way up to 599, which we may or may not see, and then it's going to jump back to the top there. So if I actually add another one and say frame count comma rect y, capital C, there we are. So now we can see the total frame count is this first number. And it starts out, that's the first time they're identical. Eventually it's going to loop. Going to be coming up soon. Right there. So now this is still going up. This frame count is still going up. But the rect y, we're dividing this number by this number by 600 to get this number here as a remainder. And then that's what we're using there. So that's kind of modulo in a nutshell. There's plenty of other videos that kind of go into a little bit more depth about it. But that's essentially what's happening is you're taking one value and dividing it by another, and then whatever is left over after that division, that is the modulo. So if you think about it, if I'd said 5 modulo 3, you would have 5 go into the 3 with 2 left over is a way to think about it. Again, there's more videos about modulo in general on YouTube. I'm not going to go and go into super detail. I'll put a link in the description of this one to a little more in-depth one that I like from another channel. So I'll put that there. So that's some of the basic things you can do with basic addition, subtraction, multiplication, division, modulo in here in order to just do some very basic animation of values. Because again, you're just affecting small number data as we go along. All right. Did I do this? I always get this backwards. I need... Nope, I had that right. Slash asterisk, asterisk slash. So I wanted to just add in a comment here. Normally when I teach this course, I start off typing things out longhand and then go into typing things shorthand. But since this is just a kind of condensed lesson, I wanted to leave off with the shorthand for typing what I've done here. All right, and I've actually showed it all in this lesson right here. So we have that there. So we've typed out this long ways. We've said rect size gets assigned the current value of rect size minus 1. Well, there are shorthand ways to go about doing this. So if I wanted to say, I'll use the exact same formatting, rect x, and I'm going to say plus equals 1. And that is just a shorthand way to type out what I have on line 17. I can go in and say rect size, that'll be minus equals 1 or whatever value. It doesn't have to be 1. I just picked these because it was much easier to see in the video. But whatever value you want it to be, it's just the shorthand of it's going to be its same self and then the math operator. So I could do rect, what did I say, y, then it was multiply equals 1.1 rect x, and that was divided equals by 1.1, and then the last one for modulo, I just want to make sure, cause, yeah, it'll be the same thing. So that'll be that one. I don't normally use. I usually write out modulo just to be safe, but there is a modulo equals operator as well. So I'll leave that there. But for me, just because I sometimes, as you've seen in this kind of live instance, get a little confused every now and then with modulo. It happens with everyone. I always type it out longhand, but you can do it shorthand with these compound symbols. So we have that right there. So that's all of that. That's the shorthand. That's how you can affect these numbers with variables and with these maths. And then since we're just applying the math to a specific element of a shape, it happens to be that we do the shape is affected. Again, if we were to not use this variable for something, if I made this 100 again, we're still updating these numbers, as you can see, but since we aren't actually applying them in any sense, nothing is happening on the screen. So the last thing I want to leave you all with is with system variables. Again, I'm going to just go record that video real fast after this, but if you're watching this in order, you will have already seen that. And we can use system variables as well. So I'm going to replace this with mouse X and mouse Y. Mouse X and mouse Y. Got that. This will default to 0, 0 because I haven't actually put my mouse on the canvas yet. But now, every time the draw function happens, it's going to check and see what mouse X and mouse Y are equal to, and then it's going to use that to draw this shape. So if I comment this out and say console.log mouse X, mouse Y, just like this, we'll be able to see exactly where our stuff is. So if I move this around, since this is drawing from that top left-hand corner of the square, that's where the shape is kind of anchored to our mouse. And then we can see in our console the exact X and Y position of that point. And then since the rect size is constant at 50-50, it's all right here. Staying the same size, and I'm just moving it around, having it follow my mouse as we go. So that's just a way you can use some of the system variables to set stuff. Later on, we'll be using things like the width and the height, but that'll be more accompanied with things like tests and other aspects. But we'll get into that a little bit later. That's just doing things with variables. So basic animation with variables. So that's that. Have all that stuff, using system variables, using other variables, using math to affect them. You can, you're then just affecting the numbers, and then you just use that number for something visual on your screen. And since the numbers are changing, the visuals will also change. So that is essentially the core of that lesson. So thank you very much. If you want, try adding some other shapes to this code. Again, you'll be able to pull this up in the collection that's in the description for all these videos. Try adding some more shapes or putting things in the console log, getting them to automatically update how I've done here. Just to see just how many shapes you can get on the screen with variables that are moving around. If I were to leave you with a little bit of a an assignment to do after that. If not, have a wonderful day, and I will see you in the next video.